powder stoichiometry. I think you are not familiar with such techniques. Are you familiar? So let me know what are the basic steps involved in processing the solid oxides. What are the basic steps? Step number one, step number
Yes.
two.
I learned 8 steps. If you want prepare any compound in chemistry, EIBA03,
Yes,
one
fine.
steps calculate and
Yes.
all steps
And what is the next?
milling and
What was the last step? Anyone of you
I understand.
are those steps? Huh?
Physics.
No, what are those 8 steps? वो 8 steps क्या कहते हैं? पहले क्या करना है, बाद में क्या करना है, then
सर
one by
पहले मोलर रेशो पहले तो सही करनी है
First
स्टोइकोमेट्रिक
of all,
रेशो
you
लेना
have
है
to
दोनों अमाउंट्स का
calculate
मुझे
the molar amounts of their specific substances. Okay?
यस
So what are the basic two steps? One method is to calculate them over on a notebook. Another way using this chemical composition calculator. And after knowing the amounts, then what was the next step?
मिक्सिंग ग्राइंडिंग
Just weighing. Weighing.
यस सर यस
Okay. So you have to measure then how much in grams do you need and what is your requirement, how much amount of material do you wish to synthesize. For example, considering the example of barium titanate, and if I am interested in its dielectric properties, so for that purpose I need a pellet just like a paracetamol tablet.
यस सर
So from there you can assume that how much amount do you need. Okay? But in parallel, I also need some amount for characterization as well. So during the characterization, some are destructive and some are non-destructive technique. That means that in some characterization methods you will lose your material, while in some you do not lose. Okay, so keep in mind that you are also going to characterize your own material. So for that purpose, you need some extra amount. So on the basis of that, you can conclude that how much is your net requirement in grams. But in advanced research, we need at least 5 to 6 different compositions of same materials. Okay? So in this way, your final samples may be 4 samples, 5 samples or 6 samples. So that means you need a huge amount. And before that also verify the cost of your material. So after that, after weighing, what is the next step?
Isn't
Mixing. So mixing is not so simple. It is not like that just to pour all the material in a beaker and then mix it as we usually do in our homes in grinders. It is not like that. It is few different. So what is the name of that equipment which is commonly used for mixing and grinding?
बालमिलर
Ball milling. Okay. It is not stirring. Stirring is something else. The stirring technique is not used for solid oxide. For solid oxide, we prefer
बालमिलर टेक्निक
although there are several other techniques which are also available in the market, in the labs, but the most preferable one is ball milling. Okay, and then the next one, after the milling. So what did you expect that how much time is required for a milling? Usually milling, if this is the minimum time. Sometimes we need 48, 72 hours like that. Okay? So what are the basic purpose of milling? One is mixing, another one
Grinding.
to achieve the uniform particle size.
Yes.
Okay, so it is preferred in research after milling, just estimate the particle size using particle size analyzer. This is an equipment which is available in MRL, but it can measure only up to 0.01 micron size. Okay, this is the minimum range of it, and maximum of 200 micron. You know the micron size. You know what is meter,
Yes.
and then foot, then centimeter, then yes, then millimeter, then micrometer, nanometer, then no, this is Armstrong, and 0.1 nanometer is equal to 1 Armstrong. Okay, and after this there are some other, but our requirement is up to Armstrong level. This is our range, especially in material science as well. So this is the reflection of our class. Okay, first of all, going into the next task, we have to discuss the previous one.
Yes,
Okay.
sir.
So what is the next?
This being D-I-Z-B-I-N-G.
No,
I
after
understand every
after
step.
mixing, what kind of material is used usually to crush the powder inside their jar during the boiling? Zirconia is preferred because it is very hard material. Sometimes we also use the titanium 304 steel, low carbon steel, and 324 number 324 steel as well. Okay, but mostly we use zirconia.
Yes, sir.
And when you have done with this milling process, so what is the next step after milling? No. So in between, you have to, yes, you have to wash and pour all of your material in a beaker and then separate the zirconia bar, and after that you have to dry your powder.
Yes, sir.
Okay. So what kind of solvents are commonly used during milling? Alcohols usually, ethanol,
Polymers.
ethanol, propanol, isopropyl, they depend which one is available.
Yes, sir.
You can also use water, distilled water. So do you know about the difference in between distilled water, mineral water, tap water, deionized water, and double distilled water? So, first of all, tap water. Tap water is a simple water that usually we use in homes, and they come directly from boring wells. Okay, it contains metals, salts, maybe some bacteria, funguses, sometimes viruses. You know the diarrhea.
Yes, sir.
So sometimes we get ill and the doctor is affected by diarrhea virus. And the second one is the mineral water. So after processing the water to kill the bacteria, leach and everything, to remove all the heavy metals, salts from the water using 4 different types of techniques: microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Any one of them is used. So after that, even distillation. Distillation is also a process commonly used for the purification of water, and it is a very hot topic because in future this is a very broad research area. If you are working on that, specifically on such materials which are commonly used for the remediation or filtration of water, so it is also a part of research. And it is broadly used in chemistry and partially here in physics. We have done one article on nanofiltration. Just using nanofibers to make a mesh and filter are very simple. They block the unwanted substances which are large in size from the pore size of that filter, and this way you can purify your water. And nanofilters are preferred because they can even filter viruses, not only the bacteria, amoebas, funguses, but also the viruses. Because you know the size of a virus, it is less than 10 nanometer. What is the size of coronavirus? It was almost 0.1 or near to 1. Okay, come on. Okay. So it is just general knowledge, and also get this general knowledge because it is useful for you. You will see today I am unprepared, but because of my knowledge I will entertain you up to 2 or 3 hours. It depends on your mood. Okay. So we were talking about our previous task, and that was the powder stoichiometry, and several steps are involved in processing of those oxides. The first one is that webbing, the second one mailing, then washing, and then drying in the oven, and then after that, what is the need of sealing? Chance. Beads to make the powder more uniform. Okay. So the next step is, what was the next step? Next step क्या? Calcination, calcination. But how one can perform this calcination process? What are the requirements of the calcination process? Huh? No. This is required, something is related with characterization, not with processing. I am talking in the contents of processing. So that is your crucible and furnace. Okay. So there are different types of crucibles. Do you know the common names of materials which are commonly used in crucibles? Do you know? The alumina,
Yes, sir.
porcelain, even zirconia, tungsten, graphite. We have all of them in our labs. And gold and platinum alike type crucibles, because some materials have compatibility with some specific materials. So in those contents, we usually change the type of crucible. Also the temperature. Okay, only this porcelain sustain up to 1000, alumina up to 1200, light crucibles up to 1100, and this is tungsten up to 1600. But for that you will need some inert environment, because tungsten is reactive with oxygen and high temperature. Even graphite crucibles, graphite clay crucibles, okay, they also sustain high temperature. And this platinum gold alike crucible, they are more stable, they can sustain very high temperature. They have very good properties, but they are so expensive. Okay, and after calcination, then maybe you have to press your powder in a pellet presser and a required pressure.
Yes.
And during the pressing, usually the powder do not adhere with each other. So for the adhesion purpose, sometimes we use polymers,
PVA.
solution like PVA, PET,
PVP.
PVC, so many others, PMMA, there are several polymers which are commonly used in laboratories. Okay. And then you have to center your pellet to get its hard form, because one is unable to hold the powder. So for that purpose, you need a hard pellet. For example, if I am interested in electrical characterization, so for that purpose, I am not capable to use the powder. So how it is possible to connect the electrodes with powder?
Sir, you will coat the pellet.
Yes, so in this way we convert our powder into pellet by just centering it, let it become hard. Okay, and what are the other advantages of centering? It eliminates the air gaps in between the particles. You know air is also dielectric, so it can change your electric properties. Okay, and okay, so you know when the baby start walking, just fall on the ground, very slowly, then after a very long period of time, he can run. At the end, he will become capable to run very fast. Okay, in this way, we are slowly learning all those things, but the most important, you need your hand-on practice on those things. Theory is nothing. Theory is available. Lectures are available on YouTube. It is nothing. The most important thing is let us come out with it. You are going here just to use the phone. If any one of you, if you have a laptop, please connect that one with किसी के पास. Okay. So once I learned that how to prepare the banusai alwa, but you know that once I have started, I know the remedy from the video, that how to, what kind of ingredients are required, how to cook this banusai alwa. But on first attempt, I was unsuccessful. I wasted my money and time. But at the second time I left, and so on. At the end, I improved. And after 2 or 3 months, in next season, in winter, my friends called me, come Muhammad Ali and prepare the banusai alwa for us. You are really doing very well. Okay, the same is the case with the material. Okay, thank you. With the material processing. If you are not doing with your own hands, you will face the consequences that are on you during your research. Okay, so again and again, I am advising you to come to the lab, to use the tool. It is available for you free of cost. You know, and late 2010 and 2005, up to 2005, only no paper was published from the Department of Physics. So even one paper. And after that, now we are publishing 40, 45, 50 papers per annum from the same department. So from where this difference comes, this credit goes to Professor Dr. Yasin, but Physics is something like practical. Okay? When the equipment comes, the accessories comes, if you have, for example, you have a very good kitchen, but utensils are not available, iron, masala jars are also not available, even salts and other requirements are not available in your kitchen. Even gas is not available in your kitchen. If all, each and everything is available, but there is no gas, so how it is possible to cook something? Today, each and everything is available in your department, but I don't know why you people are not going to utilize them. In our time, we traveled through our own pocket money to Islamabad, to Lahore, and then we always request them to please to do this. They even don't allow us to show us the equipment. Now you can touch them, now you can use them, but you are not going to do that. So may Allah guide you well. I don't know why. ठीक है. Okay, so the material processing, it is a very long story. There are several other techniques commonly used for material processing, even for the synthesis of nanoparticles, for the synthesis of thin films, for the synthesis of bulk materials, for the synthesis of nanofibers, okay, for the synthesis of composites. So later on, maybe in the next lecture or in the next one, we are going to discuss them as well. But the basic one is this one, as it was discussed in the previous lecture. Okay, so on your fingertips, you have to remember all those steps. You just master yourself by doing even crushing, pound, milling, grinding, centering, all of this with your own hands. Okay, this is my advice for you. Otherwise, you will face so many things while performing your final research work, if you are interested in, especially in material science. It is totally applied. In today's lecture, we are going to discuss little bit now see this chart. So what is the title? What is the title? 1 minus x. This x is variable. That means that you are going to change the value of x, and this is maybe the differential. And so on. You have here x is equal to 0.75, 0.67, this. You see here when the x is equal to 0, this should be 1, this should be 0. Okay, just binomial outside. But along with strontium, then you have to see the properties. What kind of properties? Dielectric properties of that binomial oxide along with this titanium oxide. But this is one kind of phase, this is another kind of phase. So this is a composite material composed of 2 or more than 2 phases. Okay. Clearly, what is the aim? Aim is to investigate the structural and dielectric properties of compound or composite, and the discomposition series. And this is written by Okay, but why I am going to show you this whole chart? Because the entire story of your research work, which is related to the especially with materials, is just not limited to the material processing. There are several other steps which are also required for the research work. And preferably, those are the characterization of such materials. So today we are going little bit about characterization, and then one by one we are going to discuss each and every technique in details, and then we will, because all those techniques, basic techniques, I have documented them here. Okay, I know them. I have installed them. I have run them. I am using them for a very long period of time. Even I am installing some relevant equipment in other universities as well. If you are interested, when an offer come to me to install some equipment in some university, then I will share the date in LinkedIn in my group, in your group, that is the material processing. If any one of you want to join me, you can come. Okay? Then this way you can learn the new things. And this is useful for you because your whole life is associated with learn. Just not stop on limited things. Learn every day new things related with your job. Okay? Because your job is what? You are the students of physics and now you are graduates. So here you will see some variations in microstructure. This is a microscale, this is a microscale. And what is this? Here you will see some variation in peaks as well.
XRD.
Yes, this is an XRD technique, X-ray diffraction technique. But what is they are relevant with each other? You see here the grain size, the grain structure, the pore size. When it is varying with respect to what? Temperature. So here the phase, you will clearly see the phase variation. And all those features are related with what? With this composition by changing these two components. So this is the art of material science. You can play with the materials in different domains. But before that, what is important? That is, here I prepared a presentation, but unfortunately, due to the lack of time, I am unable to show you, but I have the contents of the presentation which was prepared for you. Okay? So don't worry. Stay with me. See. So the title is the basics for physics graduate. This is basics for physics graduates. DFL semicolons. Or inside it, what is included? Introduction to the characterization, characteristic, properties and application of materials. An introduction to the characterization, characteristics, properties, applications of the material. Okay. Characterization, properties, applications. All of them are interconnected with each other. But once you have done with the processing, as I told you earlier, there are several techniques for processing of materials. If you need organic, inorganic component, only organic materials, crystalline and amorphous, like this. So the method will vary according to your required physical property of the material. It is not important to just know them. You just listen each and everything very clearly. Okay. So the question number one is But before that, let's discuss some funny things. For example, if you are suffering from fever and you went to the hospital and the doctor diagnosed you and he told you that you are going to die within 2 hours. So what will be your response? For example, if you are suffering from some kind of fever and you went to the Sherpa hospital and in emergency the doctor asked you some question, for example, what is your name, what is your father's name? And then in response he told you that you are going to die within 2 hours. So what will be your response? Your response is that, are you crazy? Okay, am I right? Because this is not the way to diagnose something. Because there are some specific steps, protocols for a doctor to verify or diagnose something. For example, first he asked you that what is let me show you your temperature, blood pressure, and after that the symptoms. Okay, and then he will tell you that, okay, go to the lab and do blood test, urine test, chest x-ray, similar relevant with your symptoms. Similar is the case with material processing. Once your material has been processed, what is your task? What is your next task? You have to verify. You have to verify your material. There are two ways. One is verification and one is justification. So what is the difference in between the verification and justification?
XRD, EDX.
It is something like that. If you are going to validate those things or confirm those things, this is something like verification.
Yes, sir. Yes.
And if you hope to do something, if it is done or not, this is something like justification. Okay? In material, what is the main purpose of characterization is to verify or justify your material. Is it done? Is it like that or not? Understand? For example, if you are going to prepare a strawberry juice, but after at the end of the process, you have to taste it. That it is done properly or not. But if you are blind, then how you can do this whole process? Think about it. There are also a way. This is something like justification. In their contents we have to justify, but in the previous contents we have to verify this. Okay. So sometimes, for example, if you are going to synthesize a new material, you thought that this structure should contain the following properties, and you just pick the oxides from the lab, mix them after completing or you have synthesized a material, and then you will see that it is prepared or not. Okay, this is one way. This is just something like justification. For example, if you know the material, for example, you know the barium titanate. You got the barium oxide and titanium oxide, mix them after calcination. Just verify that is the required structure is achieved or not. Is barium titanate or not? Is something extra contaminants are included? If the initial oxides are pure or not, you will identify that where I am losing, from where does this error come? If the final material is not achieved properly. Okay, so this verification and justifications help out us during in achieving our final targets, and also provide us some necessary information. If there is some error, then you will just remind the entire process in your mind, and then you will see that from where does this error come. Usually, students do errors during the giving. Sometimes they do not properly clean for example, the milling jar, the medias, before processing the materials, the crucibles, the furnaces, and at the end they got the wrong result. And then they came to the supervisor and they asked him that, sir, it was written in this way in paper, I followed each step properly, but the end result are not satisfactory. What is the reason? Okay, so you should be very curious at performing each and every step, because otherwise you will lose your time, you will lose your money, you will lose the quality of your research, and it is very difficult to repeat each and everything again and again, because at least 24 or 48 hours are required for just milling. And you know how much time sometimes material required 14 hours just for calcination, and similar for 5 hours for centering. Okay. So, do you know about the characterization of materials? This is my question. So what did you think, what is actual meaning of characterization of in contents of material science specifically?
सर इसका स्ट्रिक्ट फॉर्म मालूम हो जाए और
इम्प्योरिटी का पता चल जाए कि इम्प्योरिटी
मतलब इन शॉर्ट टर्म्स पता चल जाए, मालूम हो जाए, to know, to analyze, to understand, to verify, all words are almost similar. You know, if you have, for example, Allah na kare, if you have, for example, tuberculosis, so without doing any proper test, one can't say that you are suffering from tuberculosis. Okay. So here I have written this characterization of material refers to the process of analyzing and understanding the properties and behaviors of different materials at microscopic and macroscopic levels. What characterization of materials refer to the process of analyzing and understanding the properties and behaviors of different materials at microscopic and macroscopic levels. Okay. This is the basic definition for the characterization of materials. So on the basis of the first question, we have a second question. What kind of characteristic? This is characterization and characteristic. To know the characteristic is called characterization in short term. Understand? To know the characteristics of your materials, for that purpose we are doing characterization. And different techniques are involved to do different kinds of characterization. For analyzing your blood sample, one kind of equipment is used. For analyzing your, let's say, your urine sample, another kind of equipment is used. Similar to that, to analyze one characteristics. There are several characteristics and we are going to discuss them. One kind or two or three kinds of techniques were used. Similarly, another characteristic, another kind of thing. Okay. So what kind of characteristic of materials are important for you? Physical characteristics. So what are the physical characteristics? Some physical, but those physical characteristics are related with some other characteristics as well.
Surface morphology, grain size.
Yes, but in short term, the first one is the structural properties.
SEM.
Characteristic or properties are most said. Or maybe this is something like structural characteristics, for example, not properties, let's say. So, what are those? Those are the phase. What is phase? We are going to explain it. Another one is the microstructure.
SEM.
Another one is the atomic structure.
Yes.
Another one is the chemical structure.
Yes, sir.
It is very important.
Yes.
Phase, microstructure,
Atomic
atomic structure,
and chemical structure.
and chemical structure, or sometimes molecular structure.
Yes, sir. Material.
Grain size, particle size, according to you. And you know what are plus some other, tell me more structural properties about materials. You know the shape memory analysis? What kind of materials are those? Piezoelectric materials are something like shape memory analysis. When you apply it, they change their shape. When you apply external mechanical energy in this contents, they provide some another kind of energy. In future, you will see in movies there are some kind of material they transform themselves in some. You know the transformer movies. Transformer. Here you will see the cars running on the suddenly they are converted into the robots. This is the future technology which is coming. Through such kind of material, you will see the miracles of materials in near future. Because if once you understood the material science, it is very interesting subject. After that, you are an electrician or electrical engineer as well, mechanical engineer as well, chemical engineer as well, aeronautical engineer as well, all of the civil engineer as well. All of those engineering fields are hidden inside the material science. Okay, so it is very interesting subject. Let me know other properties, structure properties. Any other properties in your mind? Huh? Elasticity.
Elasticity.
Huh? Huh? Turbidity. Yeah. What else? These all are associated with something like hardness in short terms. Tensile strength. This is also something related. Okay, the next one is the mechanical properties. This is hardness, elasticity, strength. Then those are the basic properties of your interest in the materials. Okay, the basic properties. Here we are going basics for physics graduates. In the next session we are going to deep dive and exploring the more and more things. But before that, must remember those basic things and keep them in your mind. Okay. So the next one is the mechanical properties. The third one is the thermal properties. You know the Seebeck coefficient. You know the thermal conductivity. Figure of merits, specific speed, specific heat capacity. There are so many other thermal properties. This thermal expansion. But what is the importance of anyone who took one of the thermal properties and give me your opinion that which one is very attractive for you? And what are the applications, for example? Let's targeting the thermal conductivity. So, where it is required. Thermal conductivity. Thermally conductor and insulator. This is the definition of something like thermal. I am asking that where it is required to measure the thermal conductivity. While measuring the thermal conductivity is very important, discuss some applications.
Heat sensitivity, thermometry.
No, discuss some applications. For example, there are different types of cloths. The females know well. Some for men, there is a cotton. A cotton polystyrene blended cloth is different names, but in summer we are using one kind of cloth. In winter we are using another kind of cloth. But sometimes you will judge in your daily life, some clothes are very thick and they seem very hard, but when we get them in winter, performance is zero. So what is the reason? Because the material that was used in their cloth have high thermal conductivity. So they transfer the cooling from the outside to our body very quickly. Okay. Similarly, in car radiators, different materials are used. Commonly used materials, brass with a very high thermal conductivity. Because if a material is very high thermal conductive, it will exchange heat very rapidly. Okay. Another property. While using different types of coating on your rooftops, on your walls, preferably we use such paints with very low thermal conductivity because they protect us. They keep the internal environment cool in winters and hot in summer. Mostly you will see people use these PVC sheets on their walls, even using ceilings. Because here polystyrene is used, which is a very low thermal conductive material. So when you are going to explore one by one, you will see so many things which were hidden even in thermal conductivity. Similarly in mechanical properties, similarly in structural properties. Electrical properties. So just like thermal, there is a very basic property of electric material, that is electrical conductivity. Okay, even you can differentiate different conductive materials on the basis of their electrical conductivity, because copper have one kind of electrical conductivity. Okay. And there are two types of conductivities. This is called what?
DC
This is called DC from here. If you go, this is constant term, this is resistivity, which is specific material. It is a constant term. And another one is this, and this is related to the, and one another one, I can't remember, but this is related to the natural frequency, and this is the relative permittivity of the material. This is AC conductivity. Another one, there are three ones there in this formula. Then later on we can verify this formula later. Okay. So even considering one of the electrical property like conductivity, you can perform your PhD and postdoc even on that, even on a single property. Okay. By doing even a single property or just clicking on a single property of material, you can explore so many things which can make you capable for PhD or postdoc, or even you can spend your whole life on that specific target. Okay. What are the other important electrical properties? Here, this is the electrical property, this is the electrical property, this is the electrical property.
कैपेसिटेंस
हाँ?
भी चेक करते हैं.
This is the electrical property. Huh? This is the electrical property. What is
Impedance.
Yes. Okay.
स्टैंड लॉस भी चेक करते हैं.
This is the electrical property. What is this? Internal.
This is
Yes. Okay, we are going to discuss also explore the electrical properties of material, and I have arranged several softwares designed by my own here in MRL, and so many people were using them, and they report those softwares and experimental setups while publishing their paper. But they don't usually acknowledge me. They acknowledge MRL. Okay, so but the basic one here, there are the band gap, electrical band gap. I will show you what is the difference in between the electrical and the optical band gap. You know the band gap, I think. Huh? Sit over there. अगर मैं is the difference, this is wrong. अगर कहूँ कि potential, this is also wrong. Energy difference. We have different bands of energy levels in a material. For example, this is your valence band, conduction band, in between them, Fermi level, above it, what? Vacuum level. Okay. Vacuum level. So, the energy difference in between valence band and conduction band, it is what? This is a band gap. And it is defined as an electron force. And you know what electron force? It is the amount of order when you are going to move a unit charge from this potential, from here to here by applying this much potential. So optical band gap of the material. But also on the inside the electrical properties, we have electrical band gap as well. So almost electrical and optical band gap are near to each other. But the electrical band gap is few electron volts above the optical band gap. In optical band gap, usually we provide the energy by lambda, okay, to this electron in the form of what? In the form of light, and it jumps into the from valence band into the conduction. When if this energy is sufficient, when it comes back, it may be emission, emit some light. You know different phosphorescence, fluorescence, luminescence may be happen. So from here we can estimate the band gap. But electrically, what we do, we excite this electron with the help of applied electricity. But in that case, what happens is jump from here to the vacuum level, not to the conduction level. Okay? So for example, let's say this is the band gap of optical band gap of titanium dioxide, for example. So this should be the electrical band gap of titanium dioxide. In that case, the Coulombic force, you know the Coulomb's law, the force of attraction and repulsion. So in this case, the nucleatic forces do exist on that charge or electron when it jumps from the valence band to the conduction. If it is in the conduction band, it is in interaction with the nucleus in this case. Forces exist, but in this case, when it is here, no forces. Okay? So that's why electrical band gap is few above than optical band gap. But this is something like general knowledge. So electrical band gap, electrical conductivity. So one is AC, one is DC. But considering just the DC conductivity, so there are two ways. One is two-probe technique, and that is very important for you as well. Even on finding simply just the conductivity of our material, people can publish their papers. I will show you recently, just Dr. Physicists synthesized a composite polymer, and by reporting its conductivity, he published a paper. Because usually polymers are not conductive, but in most of technology you will see that those polymers are also conductive. You know that it was invented by conduction in polymers was invented by I.O. Frege, and he got the Nobel Prize on that. And today we see the miracles of this polymeric electronics, like organic electronics. It is a broad field. This field belongs to the Dr. Mohammed Shah. Okay, organic electronics are polymer electronics. And now you will see in future the flexible displays, flexible laptops, flexible solar cells, and flexible electronics and appliances. Lightweight, easy to fabricate, printable technology, all of them because of this conduction in polymer. So electrical conductivity, one is the DC and one is the AC, but the technique for the DC is just two-probe technique. For example, if you have a wire here, later on we are going to discuss them in depth as well, each and every one. It is just the glimpses for you. This is just the basic. Okay, if you are not interested in general knowledge, you are getting bored, I think you are getting bored. So we will go on to the next. And if you are interested in the general knowledge, then we have to continue. Because the general knowledge is very important for the research. research is not a thing like that if you are very intelligent, if you are very studious, research is totally depend on your brain. If you are just pitching your ear like this and like this, approaching to your target in a very precise manner, okay, this is the best research. Okay.
Yes, sir.
If you have the general knowledge, you can do research easily on so many things. It is very easy then. Otherwise, if you don't have the basic knowledge, even if you don't know the applications, if you don't know such kind of knowledge, it will be very difficult for you. If you know all of these things, at the end of it, you will know that it is a very easy task. It is very easy as compared to your manipulation, FAC. It is difficult because at that time you don't know the things accurately, the science, but we just going to memorize all of those things in our memory and then writing and writing and writing. So such kind of things are in the first place because here the things are practical, more logical. And you will see all these things with your eyes, you will feel it even with your senses of knowledge. Okay, so first develop your senses, not your knowledge, senses of knowledge related to the science and then to material science. And then come into the research, then it will become very easy to understand. So conductivity. So here in the formula it is very easy. For example, this is the diameter, this is the length here, this is required, and we know this formula in fifth or sixth class. This is the diameter. So what is the formula? Area. And here is the length. And then just apply here what? Voltage and measure here current. And you know the formula V is proportional to I. And you know V is equal to IR because, and this is the case, formula is only for linear bilateral device, not for the semiconductors. Okay. From here you can easily derive what? Resistance. Alternatively, if you derive this, you know the L, and if you know the A, and this is derived, what is your end product? Resistivity. That is the property of your material. If you don't know your material, just derive this and state that this is planar material, this is copper, this is aluminum, this is tungsten, this is gold. Suitable for all kind of conductors, not semiconductors. Okay. And similarly, if you know that, and if you derive any novel property, and just by relating this property with temperature, T is proportional to R in case of conductor, you can do the same process even at different temperature. If it is done here, then your requirement is there to design a superconductor. This is the hard area of research. So on the basis of these two formulas, you can even modify a material to get its superconductive properties as well. You see, it is just like formulas continuously. We see such formulas even in metric and FAC, but at that time we just try to memorize them. But here we are going to sense them, so where they are applicable, how they can help us, or how they can sort out different problems of our daily life. Okay, this. So another one is this 4-probe technique. because such technique is suitable for such kind of highly conductive materials, not for semiconductors. The materials whose areas are defined. If you have material like this, so what for that? Is it possible? Of non-uniform thickness, non-uniform length, non-uniform shape. For example, if you take the thin film, so what will be the case here for thin film? So for that purpose, we use the four-probe technique. Usually this voltage in ampere is measured by the same meter, and that is called the multimeter.
Multimeter, yeah.
But in that we usually use the source meter because the source meter is usually more accurate as compared to. I will tell you that how it is more accurate. So in this background, if the material shape is irregular surface and it is a bulk material or whatever, so in this case, usually we use what? Four-probe technique. All probes are equally displaced from each other. Okay? And these two probes usually apply voltage and those to measure the current. So in this way, the probe resistances are eliminated from our measurements, and also the area, the geometric factors are eliminated. Okay? So if you face such kind of problem, then you have to use what? And another aspect is the conductivity, the AC conductivity usually used for dielectric materials. You know what are the dielectric materials? What? In simple words. What? Now those words are not for LMA. They do a poor conductor. This. Usually, such materials, when they are exposed to the electric field. Yes, but element don't know about polarization. And in that case, when it stores some amount of energy and release dissipate some amount of energy, such materials are called dielectric materials. Okay? If they just dissipating the energy, they are purely resistive material. If they are just passing the energy, just like that, they are conductors. If they are storing and also dissipating some amount of energy, then such kind of materials are what? Dielectric materials. You know that the dielectric material, they are in terms of dielectric material, you usually refer them to the impedance, not to the resistance, because here you have two parameters. This is the reactance, actually dissipated energy, and this is the energy stored per cycle. And collectively we call it impedance. So while performing the electrical analysis, while doing the impedance spectroscopy is also very powerful electrical technique. You know that. Even today, there is a whole journal on impedance spectroscopy. There, one is the solid state impedance spectroscopy, one is the EIS, electrochemical impedance spectroscopy. Both are very important, but electrochemical is very, very important for chemistry, and for us, what is important? Solid state impedance spectroscopy. And if you learn even this, you can easily do your MPhil, your PhD, you can even publish paper within days. Okay, I will also share this technique with you as well. But now we are going to discuss just basics. Those are just basic names, basics, and similar to that. There are so many, but the basic one are what? Impedance, capacitance, not the series capacitance, parallel capacitance.
Yes, of course.
The capacitance because of that dielectric material, not because of that electrode. Resistance, AC conductivity, tangent loss, sometimes called dissipation factor, the energy which is not stored but also not delivered at the output.
Yes.
Not dissipated as it, but also not delivered to the output.
Yes, sir.
Okay? Because actually it is stored. And real and imaginary part of the impedance, reactance,
Yes.
AC conductivity, file, and the most important, the relative permittivity. For example, if you know the capacitance, so you can derive what relative permittivity. Okay. This was done by the what? This, for example, this is your figure. It is just like a capacitor, the final product of your Paul's spectrometry, and it is coated on both sides, silver coated, gold coated, or whatever. So you know the diameter of this metal, the thickness of this metal. So here is what? Here is the thickness. This can be derived from the diameter. This is the relative permittivity of the free space, farad per meter. Farad per meter में होता है ना? Okay, and this can be derived from what? Through the LCR meter from the instrument. So, knowing all these parameters, you can derive the relative permittivity of your material, also called dielectric constant. Clear? हाँ? नहीं अभी तो मेरे ख्याल में पूरा इतना लिस्ट बाकी है. Just a minute, hold on.
So,
Energize yourself because it is very important. Otherwise, if the flow is interrupted. Usually, I know your faces. If you are getting bored, I don't know why, but maybe sometimes.
yes,
Usually, I target some other task in my mind and then sitting somewhere else. In this way, you can bore yourself. Just if you are here, just focus here. If you are there, then focus there. Okay, सही है तो वो होने का. If you have some jobs or some other things, let me know. Then we can close the class. Do you have any precious activities, important activities?
सर रिलेटिव परमिटिविटी के बारे में थोड़ा बताएं.
हाँ, वो हम डिटेल में जाएंगे. वो पूरा उस पर एक लेक्चर होगा.
जी सर.
और ये जो सारी चीज़ें हम बता रहे हैं ना, later on I am going to give you a lecture on each and every word which was discussed here. Here the first one was the structure property. So there are so many structure properties. We are going to explore the important one and then discuss one by one, and then the mechanical properties one by one, then the thermal properties one by one, then the electrical properties one by one, then the optical properties one by one, then the chemical properties one by one. Those are the basic properties or characteristics of a material that must you have to know before performing a research type task, because they will help you in designing your what? The last one is what? Application. If you are going to design the Imran Khan shoes, which are very famous today, so what are the properties of these shoes? You must have to know them, and then you have to design something new, which is superior than that, which can gain the attraction of customers in the local market. Otherwise, you will lose your time and money. So don't lose your investment. Okay. So what are the major properties? One by one. why Shabai? Mechanical properties, thermal properties, electrical properties, magnetic properties. Magnetic properties is a huge field. Optical properties is a huge thing, and chemical properties is also very broad. But the third question, now the two questions are discussed here. The first question was what? Do you know about the characterization of material? Your answer was yes, and you told me that this is the actual meaning of characterization. And I have given you an example of a doctor just for verification or justification or validation of something or knowing something or like that. Okay. The next question, what kind of characteristics of materials are important for you people? So the answer was that the basic, the structural properties, the mechanical, thermal, electrical, magnetic, optical, chemical. Okay. I'm not going into the depth because I feel that you get bored because also even the electrical properties is very lengthy. Then optical properties. There are so many miracles just of photoluminescence spectroscopy. I have a lecture and I think it will take at least 1 hour to give you the basic of this photoluminescence spectroscopy. Excitation, emission spectra, excitation intervals, band energy gates, different energy bands in the materials. Okay, and this is even lifetime. That how much an electron can stay in this shell, this shell, and this shell. From where does this energy is emitted, from which one shell, from which one shell, from which one shell. Even calculating the band gap using the PL, even calculating the color indexes from the PL. There are so many broad applications of. Then you invisible spectroscopy. Even it is used in chemistry, in physics, in botany, in industry, in so many places. But just in 2 hours we are going to conclude that. Then FTIR, XRD, XRF, VDX, XPS, PL, HPLC, so many. So the next question, what are these characteristics applied, where they are applied in physics? So they are applied in material science, nanotechnology, solid state physics, optics, electronics, and blah blah. The fourth question, commonly used techniques for the characterization of material. For example, now you know what is meant by characterization. What are the basic characteristics or properties of a material that you are interested to know that what are the
Phase
basic
analysis, XRD.
No, it was already discussed. These are mechanical,
Yes, sir.
structural, thermal. But how to estimate, for example, considering the structural properties, just consider for the time being the phase and atomic structure. XRD. But what are the basics of XRD? This is, you know, the Black's line shirt formula. Okay, but how does it work? How X-rays are produced? Are they single wavelength? Okay, how the entire process goes on? You don't know those things. How to analyze the data? How to see the HKL values? How to match phase identification? For example, if your task is to identify the phase, this is the barium titanate phase, glucite, nataz, there are so many phases of barium titanate. Which one phase? So how can you identify?
So different software use करते हैं.
The basis of cards which are available, JCPDS cards. ठीक है. But how to? This is just like how to justify. If you are going to modify, for example, if you are going to modify a structure, for example, the previous structure was ABX and A side, for example, you have calcium. and you are going to replace this calcium with something else, and then you have to study the structure. So in that case you have to verify your work. If you have different composition, all composition are not included in it. If you have multi-phases, if you have some kinds of amorphous and crystalline, both phases merge in a unit device, then, so there are so many questions inside the XRD even. Then you have a microstructure, same. Even same, you know the same, came in electron microscope. Okay, so there, how does it work, how electron comes, how they scan, what is your target, what are you going to identify from the same. Okay, that's very important. But what is the purpose of identification? For what purpose you are going to identify the morphology? What is your target? Here, for example, as it was shown in the presentation, they were interested in what? They were interested in the dielectric property by wearing TiO2 and strontium. But they have some valid reasons that why they are just wearing the strontium and the titanium, not the remaining. It was already discussed in the introduction section. But if you don't have the reason, you are doing the things randomly or just do this one, then this one, this is not a science. You must have some solid reasons, some references. Okay? Then transmission electron microscopy. There are low resolution and high resolution. This for atomic, even you can identify this. You can see these spaces with your naked eyes through such techniques. However, it is impossible. XRD just give you a pattern, not the real-time pictures. Even there are so many limitations of XRD. If a composition is less than a 5% in a total range, then this technique will be unable to identify. If you think about that, if something is like 0.001%, then how you can identify? Then TG and DTA, how one can know this is dehydration, dehydroxylation, gas transition, centering, calcination, annealing, melting point, boiling point, all these temperatures. How can you know that this is the required temperature, this is the required temperature, exothermic, endothermic energy variation? Then the elemental analysis, EDX, just elemental analysis. For example, if you have a piece of rock, for example, if you blend some elements in some kind of material, for example, where you blend this titanium and something else, and the quantity is very less, and the XRD was unable to verify that there is a titanium inside your composite, then you have to perform what? EDX. Maybe it will identify it. Or there are some other applications of EDX. XPS analysis, XRF analysis, then VCM analysis. Recently I have installed a VCM, vibrating simple magnetometer, ferromagnetism, antimagnetism, paramagnetism. There are so many kind of magnetism and so many dipole movements in materials and different temperatures and different frequencies. So how you can identify it? And without knowing anything, how can you conclude your task and designing some kind of application? Then it will be impossible. Okay, HPLC are simple PHC liquid, FTIR, PL, you know, visible, and some Wicker hardness, UTM, Wicker hardness test, LCR meter, network and dielectric source meter, dynamometer, ferroelectric analyzer, cyclovoltometry, solar simulator, pH meter, vestometer. There are so many other which are available here. And only here we are only those are discussed which are available here. AFM. AFM
सबको प्रोजेक्ट दे दे फिर सब
तो मैंने तो दिया है ना उस दिन
सर वो
मैंने
तो सबका
नहीं
सेम
था।
है।
सर उसके लिए मटेरियल चाहिए।
तो आपको आप में कौन सा बंदा मेरे पास आया है कि सर मैं ये प्रोजेक्ट स्टार्ट कर रहा हूँ मुझे मटेरियल तो आप आए।
सर ये बोल सर
आप ना करें आप कोई और चीज़ करें लेकिन कुछ तो करें ना डू समथिंग।
सर हमने किया था ये इसमें
किया था तो ठीक है डू इट समथिंग एल्स कुछ और चीज़ करें लेकिन देन आफ्टर दैट यू हैव टू करेक्टराइज you have some scientific evidences on the basis of which you can conclude or you can argue something and then switch the same material in some kind of application. Okay, so this is the that was our third one lecture.
Yes, sir.
Third one. So in the next lecture there are so many other material processing techniques, but the most important was that one for you. Okay, and even if you are going to discuss the polymerization techniques, so there are thermal method, chemical method, light depletion, there are so many other methods. Even there are several other techniques used for centering. You know the spark plasma centering? There is another kind of centering mechanism which is not available here, but in that case, along with pressure, you also apply the temperature. Okay. So advanced techniques and so many other, you know how to synthesize thin film, spin coating usually used, drop casting, dip coating, doctor blading. Okay, thermal evaporation, sputtering, molecular beam epitaxy. So for even a single thing, there are so many other things. But in each case, when you switch the technique, the property is definitely switched. And the most suitable example is that, for example, if you have a piece of brown sugar like this, and I ask you to dissolve this piece of brown sugar in water, then assume how much time it will take. Otherwise, if I told you to grind this and then dissolve it, so assume that which case would take longer time. The first case, what is the scientific reason behind this? Surface to volume ratio. Because in the first case only this surface is reactive. Volume was like this, the surface was like this. But in this case the volume is same, but the surface is increased. Increasing the surface area though, because the reaction are taking place. So similar is the case for the nanotechnology. If you are dealing with barium titanate in bulk format, that will give you one kind of properties. All these electrical, mechanical, thermal, optical, magnetic, dielectric, or whatever. But when you are going to deal with same titanium on the nano scale, you will see the results will change. You will see the improvements. Okay. In the nano scale, even by changing the microstructure at nano scale. For example, this is your nanoparticle, nanofiber, nanowire. Difference in between the wire and fiber is what? The fiber diameter is almost not uniform, the length are also not uniform, so many different lengths. But the diameter and the length of the wires are uniform. Core shell nanoparticle, the shell is of one material, the core is of another. Then this type of spherical, different geometries are involved here. Triangular, rectangular, even flower type structures. We have studied it. They reflect different properties. For example, all of them are barium trigonate. C3 का भी क्या? हाँ? हाँ? बस ठीक। Okay. Yeah, and then even in the form of thin films and in the form of bulk materials, there is a more different like this. You see, the same material will take different properties while changing its physical structure. Do you understand? Okay, then we have a lot of materials, different types, thermoelectric material, piezoelectric material, electrokinetic material, photoelectric material, even in electrical side, triboelectric material, electrokinetic material, dielectric material, piezoelectric material. In electric there are so many. Similarly, in each property, with each property, but then there are some clues in each field. For example, if I am interested in thermoelectric materials, I know all the thermal properties, thermal expansion, thermal conduction, Seebeck coefficient, figure of merit, like this. I know all these techniques. I know the application of thermoelectric materials, but how did I know that which novel material can I design? So for that there should be a basic clue for each and every material in each and every group. For example, for thermoelectric material, it should be highly electrical conductor and low thermal conductor. If these two rules obeyed by a material, that material should be a best thermoelectric material. Then, but from where does this electrical conductivity comes? From where does this thermal conductivity come? They depend on what? Atomic molecular structure. And that can be identified from their spaces and like this. By playing with atoms and some atoms, where they are located in periodic table, what are their atomic weight, what is the electronic weight. And this way you can design the novel materials and you can test their properties, you can verify, you can characterize them, then justify their properties. For example, once it is verified that the all phase XRD and all ACM and each and everything was done, then measure the thermal properties, electrical properties, and then for most valuable research work, switch them in some kind of applications. For example, if this material is done, it produces excellent properties, its efficiency is far good than the others, so then connect an application with it. For example, if I put this material on a hard surface on the back side of a solar cell, so it will convert the dissipated energy of a solar cell in the form of, which is present in the form of heat, in the form of solar, into the electricity. So in this way I can increase the efficiency. We have a patent on it, combined photothermoelectric generator. So the research is very easy. And now you have AI tools. Don't worry about your English, don't worry about grammar, don't worry about punctuation, like there's so many things in text. Don't worry about the structure, don't worry about the mind maps, don't worry about how to organize the things, don't worry about the contents. Just rotate your brains and produce the things. And just start publishing the papers from the next day, from today. तो आप लोग बस पेपर स्टार्ट करें अपने लिए टाइटल ढूंढें कंसेंसस एक सॉफ्टवेयर है कंसेंसस तो वो उसको जब आप रिसर्च क्वेश्चन देते हो दिस इज एन एआई कंसेंसस तो when you ask him a research question, I will share a link with you as well. For example, what is your research? Actually, sometimes we thought that is this was done by somebody else or not. This question is scientifically correct or wrong. For example, if you before going to your bed, you thought that tomorrow I'm going to start research or thermoelectric, I will take this material, I expect this result. So is your idea is scientifically accurate or not? Just give your research question. Create software and he will show you in the form of graphs that it is 100%, 75%, and which 10 papers are most relevant with your research work. And from here you can start your literature review and go on and take the new science and the existing science and do your research. So it is easy. Huh? There is an African boy on YouTube. When he done something, then he say nothing but do like this. What does that mean? That means that it is very easy. Okay. So